we are devoting the series to exploration of interdisciplinary work on campus. And our primary interest in this series is to highlight ways in which humanistic and artistic perspectives can be integrated into interdisciplinary activities. Right? So we really want to celebrate the work of humanists and artists in particular in doing and contributing to meaningful and important interdisciplinary projects. The series meets every 2 weeks. So the next one will be on the 9th of November, right here at noon. Muhammad Khalil from Religious Studies will be giving a presentation entitled Teaching Islam Through Music Videos. So that will be on the 9th of November. Today we're very pleased to have with us Professor Raechel White. Professor White is an assistant professor in geography, environment, and spatial science, and has been on the faculty at MSU since 2014. She earned an MS from the University of Idaho before moving on to Penn State, where she earned her PhD in geography in 2014. We have Idaho in common. I was a faculty member there and she was a student there at school. She is trained in satellite image analysis and human factors methods. She also runs, paints, grows orchids, does woodworking, and raises pets. She's with us today to deliver a talk entitled Imagining the Past, Remote Sensing and Our History. Professor White.
Thank you, hopefully there doesn't need to be anything done to this because I can't reach behind me. So the talk title for today was quite a bit longer. I shortened it to Imagining the Past, Remote Sensing, and Our History. So where do I sit with my own research? As Michael said, my background, my training from undergraduate all the way through PhD has been in satellite image analysis. And during my PhD, I started to shift or get caught up in a couple of different areas, so still keeping the remote sensing image kind of central to what my interest is. So the majority of my research is around remote sensing applications. I publish in remote sensing journals, I do image analysis, but a big side area, the side that I really love, has to do with the history and the role of human factors research in developing our understanding of remote sensing technology and current remote sensing applications. And in the honor of do what you love and love what you do, I figured this would be a great time to kind of talk about some of those side projects and how I'm trying to integrate that into some of the more traditional remote sensing work. My method that I use, I really haven't found a method to my madness yet. I hoard air photo interpretation texts. I have texts even before air image analysis was done. I kind of focus between 1918, when the first air photo interpretation text really started to come out and we started to formalize this idea of how do we read air photos, to about 1960, when we see the Office of Naval Research coin the term remote sensing, and we kind of see this change over to satellite technology. I love digging through the digital archives, so the National Archives, and Library of Congress, the USAF archives is not digital, but you can still get a lot of information from them. I'm currently working on a grant to transcribe a series of interviews done with air photo interpretation experts through the American Society of Photogrammetry and Remote Sensing. I started as an undergraduate with that organization and have played various roles in leadership with them for the last 12 years. And we have a large collection of interviews that were videotaped with some of the senior analysts for a period of 3 or 4 years, but nobody's ever done anything with them other than make a short video. So we're gonna see what we can dig up through there. Like I said, image analysis, both manual interpretation as well as statistical methods of analysis. I really try to go beyond geography. Geography, we label ourselves as interdisciplinary in and of itself because we have people all the way from human cultural issues, environment, social justice, all the way to hydrology and geomorphology. But looking beyond that, international security and military history have been pretty important to me. And then most importantly, try to keep an open mind and try to go and learn from others. And I'm hoping that that's what today will be. So I try to organize this, as every geographer does, in relationship to space, or not necessarily spaces and what were satellites and things like that, but spatial scale. So we're going to start with this idea of what space is within the discipline of remote sensing and geospatial technologies, then kind of work our way down to the individual. So for those of you not familiar with the term of remote sensing, basically what we're doing is we're scanning the Earth with some sort of a sensor. Most often we're looking at multispectral sensors. Landsat's probably one most of you are familiar with. And the reason that we do it in science, the justification we give is that it gives us a multiscalar approach, ability to examine the Earth's surface. The multispectral capabilities of most of the sensors that we tend to use give us the ability to see things that we can't readily see with our through visible sight. With the large number of satellites that we now have orbiting the Earth's surface, we have comprehensive collection of data almost daily at a range of scales, and it's efficient. We can take a much larger swath of the Earth's surface looking at a satellite image than we can standing down on the ground and trying to see as far as we can see. Remote sensing started back way before we had planes. We had early kite photographers. This here is Black's first aerial photograph of Boston from a balloon. And now today we've kind of brought it back to the individual control with the idea of the use of UAVs or UAS systems. So we see this relationship between human and machine, whether that machine is the computer doing the analysis or the machine collecting the data, and we'll talk about that in a minute. The problem with using sensors like these, not so much the drones, but in some cases also drones, is that there's a lack of stability in the images that we capture. So it's very difficult to capture stable kite or balloon imagery. And so it took us a while to get from those types of platforms to a stable platform that we could use for systematic collection of imagery. So this is an example of a kite balloon image taken over Boston's Arnold Arboretum in 2013, and you can kind of get the same effect as you would have if you had a balloon image from the 1800s. This is a digital image, obviously not analog, but we still see some smoothing, some jitter from the camera not being held flat. So what happens then is we see with the invention of the airplane a new mode of capture that allows us a much more systematic viewing of the Earth's surface and allows us to organize our information about the Earth's surface in a way that wasn't possible nearly as easily with kites and balloons. So next, we're going to move into the nation and the nation scale idea of satellite imagery and how different nation states played in the development and the movement of technology from these early balloon and kite and even air platforms to satellite image analysis, satellites. There's a lot of arguments for why we would use satellite imagery, especially with intelligence applications. We obviously have a whole nother area of research on Earth observation. I can talk about that if anyone's interested, but for the most part, we're going to look at how the government pushed forward some of the innovations that we saw during this time period. So we can use satellite imagery for treaty verification, so arms deals, different types of threat assessments. So a big reason that we started developing and putting a lot of money into the development of new technology for satellites and air spying, the U-2 planes, was this threat assessment. Actually, this week is the anniversary of when we used air photos to assess the potential damage and threats associated with the Cuban Missile Crisis back in 1962. And NGA has a great little timeline of some of the imagery as well as the analysis that went into that. And then also, one of the things that we see a lot in probably mid-century literature is this idea that having all of this imagery and being able to see what our neighbors are doing could maybe increase our abilities to keep peace and reduce war. One of the critiques, though, that we see emerging out of this use of imagery for these applications is that it's a very procedural, it's a very systematic and strategic use of imagery. So instead of just looking at an image and deciding what you see, there are checks and balances, there are checklists even of things you're supposed to look for, how we view the image, what different aspects of the image we're using to make observations. And then it's also been based mostly on military applications. The reasons that we see high-resolution satellite imagery today are all based in the idea that we were running against Russia and the development of different types of technologies during the Cold War. So in 1978, President Carter issued the Presidential Directive 37, which limited our image resolution to 10 meters for non-military purposes. This is doesn't necessarily have a strong impact on our general civilian uses of imagery. For example, agricultural, forestry applications tend to use different coarser resolutions at that time anyways. But by 1988, we start seeing this interest in creating and being able to use much higher resolution imagery. And so in that time, those limits that we had on satellite image resolution were then changed. And now if you go, you can buy imagery from Planet Labs that has sub-meter resolution for very cheaply. During the time period of the Cold War, all the way up through the early 1980s, there was a veil of secrecy around what we were doing, what we and other nations were doing with our satellites and with our images. In 1954, we started Aquatone and Oilstone, a collaboration between the CIA and the Air Force on developing the first spy plane, the U-2. Up here is an image of a U-2 that's at the U.S. Air Force's museum in Dayton, Ohio. And then in 1956, we started to launch reconnaissance balloons over the Soviet airspace. Obviously, those flew low enough that they could see them. We ended up having problems, and we kind of foresaw this already. And so we started with, in 1956, WS-117L, which was later called the Corona projects, to develop the keyhole satellites, the Discover first, and then the keyhole satellites for taking imagery of the Soviet region. In August 18th of 1959, we had our first camera sent into space on the Discover 15. So this is part of that Corona and Discover progression of satellites. And from then, we had the abilities to look at Russia without worrying about things being shot down. If you're not familiar with the idea of the U-2, so the U-2 planes were flown over Russia, but in 1956, Gary Powers, one of the Air Force pilots that was tasked with flying them, was shot down and put on trial with the Soviet government, and that really sparked us putting a lot more effort into being able to fly satellites, because the satellites were high enough up, we didn't have to worry about getting shot down. Well, we knew that other states would also be trying to create satellites and spying on us. And in the early 1980s, or prior to the 1980s, US and Russia were the two dominant forces in the satellite imaging, with satellite imaging capabilities for military intelligence. But towards the middle 80s, late 80s, we started to see this interest in understanding and knowing what the government was actually doing. Because if you look at some of the early 1970s, late 1960s literature, what we see is the government trying to cover up this Discover and Corona satellite research by claiming that it's for utility purposes, for Earth observation purposes. And so as things start to leak out, as things eventually do, we start getting questions about whether the public should really know about this and how much should they know. So by 1992, Russia was already selling high resolution imagery. You could go, depending on what the area was and their approval, and buy 2 meter resolution imagery from the KVR 1000 satellite. In the United States, it took us a little bit longer. Our first commercial satellite that started producing imagery at that resolution was ICONOS in 1999, or first commercial satellite, sorry, in 1999. We also started along the same timeline thinking about other uses of imagery. So we have these military applications, we have NASA and some of the Earth observation applications. But we see this idea of MediaSat come along in the mid-1980s. It was first brought up by the Office of Technological Assessments in 1987, but it was this idea that we could have a constellation of high-resolution satellites that the media could use specifically for news outlets. Kind of ironic, seeing as today we have so much freely available imagery that's available via all different types of commercial organizations. Other questions that arose out of that are, what happens when we do release it to the public? There's been this narrative that experts were always needed to interpret imagery, and we'll look at that in a minute with the individual. So what happens when we put it in the public's hand? Well, looking back now, nearly 20 years later, with the ideas of crowdsourcing and freely available imagery and things like Google Earth or Google Maps, we see that humans really don't have that much difficulty in observing and understanding the Earth from above. In 1994, Clinton's presidential elective 23 opened up the private sector for remote sensing. So now we could have commercial satellites that are taking images of the Earth's surface and collecting data and selling that data, still under the watchful eye of the US government, but relatively freely available. So we see in the 1990s this shift in what we know about satellites. Up until this point, a lot of what we've learned was through leakages, through firsthand encounters. But then in 1995, Bill Clinton's executive order 12951 and 12958 start the declassification of not only documents surrounding the Corona project and the Aquatone projects, but also the images that were captured. So if you wanted, you could go to the USGS website, Earth Explorer right now, and download any of a number of Corona images to look at. So the scene. So now we're coming from a national and more of a political idea of what the image is and what the use of imagery is to the scene. And so in remote sensing terminology, we tend to call the image itself, so a one Landsat image, for example, a scene. And this has completely different implications in how we think about remote sensing imagery. And I was very fortunate enough to work with the Broad Art Museum in they had a writing residence for graduate students my second semester here, and it was all related to the Trevor Paglen displays, which hopefully you've all heard of and seen. And through that, I started to kind of discuss and learn about the way that different disciplines think about the landscape and different ways of viewing the landscape, and how those kind of parallel within the remote sensing discipline of how we view the landscape. So within art, we have this idea of framing, and specifically within landscape paintings, we think about this removal of the subject and this focus on the scene itself. And so there's this distance that we build into the artwork. And when we look at imagery like this Landsat 8 image, we see a similar type of relationship. One of the other things that we talked quite a bit about was this idea of the sublime, and what does it mean to be sublime? What does it mean when something is sublime, and how does that play into different aspects of landscape painting? And so some of the parallels that we drew have a lot to do with how do we use this imagery to invoke responses from things like climate change or environmental change. And then finally, thinking a bit beyond that, there's a great art historian, Saint Amour, who has looked a lot at the idea of the remote sensing image as an abstraction of the landscape in such a way that it reflects some of this more cubist type artwork. So how does that play into science? Well, when we start looking at satellite imagery, and there's one missing. Oh, okay. we start looking at the satellite imagery itself, our goal as scientists is to abstract. It is to dissect and cut apart and make simpler the environment. So here we have an image of Sandpoint, Michigan, up in Munising. This is a NAPE image with a 4-meter resolution, or maybe it's iconos. And then above what we have the traditional remote sensing result, which is a classification map of identifying different parts of the ground. In this case, it's a change analysis, so you have the wetland area, the beach area, and then sediment transfer around the point. So we can see how a lot of these ideas about what the environment or the landscape is kind of transfer over to the technological side. But I can tell you, as a remote sensing analyst, we don't think about these things. We aren't exposed to these things in our training. We're exposed to physics, we're exposed to statistical classification. And so it gives a really different perspective on the types of things that we're doing with our imagery. Some other questions that this also brings about are these power relationships. So when we're making decisions about how to dissect this environment, we have things like the FAO's land cover classifications or the USGS's land cover classifications, and they tell us what parameters we're going to use to make a decision about this is a wetland versus this is a lake, for example. And based on that, we apply those to the images and then we get some specific output. But it leaves out a lot of the representations of other types of knowledge. So for example, in this case, having someone do this classification who's familiar with the area, and it would tell you that there's a lot more complexity to that landscape than what there is in this image. We have the Coast Guard stations, we have actual shipwreck debris. There's a lot more to the landscape, and what we end up doing as remote sensing analysts oftentimes is take these very large-scale classification systems like the FAO and apply it to an environment at a scale that's not probably, isn't necessarily conducive to the type of knowledge that local people have about those scenes. Now, if we think about it from an intelligence perspective, this is an example of the Battle of Cantigny in France. And this was the first American offensive battle during World War II, or during World War I. So here is the original air photo image. This is the interpretation conducted by the image analyst. And then I was going to put some of the text that they actually had. So for each image or set of images that were flown back, we have a catalog of a written report with the images, we have ground-based images, and then we have these aerial images with what the Mylar overlays have written on them. And so we can see in the same way, we're taking those same aspects of breaking apart the environment and figuring out what objects are specifically useful for that particular application, but we're removing a lot of the personalization of that data. So there were homes there, there's people living there, but it's been removed. So what's one way that we can try to bring the individual back into remote sensing? And this kind of brings us to our last scale of analysis or thinking. If you've read anything by Virilio, hopefully you have, he has a very critical look at the way that we capture images and this idea of the image machine or the vision machine. And we can think of an idea, and we're kind of trying to approach that in today's remote sensing image analysis, where we move from an analyst or a human being taking stock of what's in a photo and understanding that photo to trying to move it to machine methods and having the machines also interpret the images different machines are capturing. So the process of image interpretation, with its roots all the way back in 1918, we kind of already looked there, is this process of identifying and signifying the different objects of importance within an image. So this is an example of an image analyst with a mosaic of photos, and they're trying to understand what are the objects of military importance within those photos. And in the beginning, we started out where we did just look at them in random patterns, and try to identify things. And we see throughout the historical texts between 1918 to about 1920, 25, where we start to formalize the ideas of what we should be looking for. And by 1960, a paper by Charles Olson comes up with these image interpretation elements. And these elements are the visual cues that we suggest should be used when interpreting images. So the first things you would notice are things like tone. So back then it was black and white imagery. Now we've added color kind of together with tone. And then we have shape, size, pattern, texture, shadow, and association. And for those of you who have done any kind of digital design work, you're going to notice that they're very similar to Jacques Breton's visual variables that came out in the 1960s. So we have these very specific visual qualities that we're using to identify very specific objects, and kind of very much focusing our observation for very specific tasks. And if we look at the different texts, so this one is The Face of Earth as Seen from Above by W.T. Lee in 1922, we see it reflected in the different texts that come out. Early on, we see them in war, military texts, so training and tactical manuals, for example. But then as these analysts come out of the military, we start to see them in more popular cultural type books. So we'll look at an example in a second here. This example here is one of the first air photo interpretation books to come out for the general public. So how can we use those different documents to understand the air photo interpreter's experience with interpretation? Well, unfortunately, there's not a lot of there are a lot of books about air photo interpretation, intelligence, reconnaissance, Cold War, coming out of a variety of different disciplines. But unfortunately, there's not as many that are about specific interpreters. An exception to this is Constance Babington Smith. She worked for the RAF in the Central Interpretation Unit, and it was actually the person who first identified the potential of air missiles in out of Soviet imagery. So imagery of the Soviet Union. She actually has written several books. One of them is Evidence in Camera, which recounts a lot of personal stories of fellow interpreters from that time period. And she actually has a movie that also has her in it. It's not necessarily specifically about her, but she's one of the more popular names that you'll come across when looking through the books. Going back to this idea of the sublime and changes, how does change in visual perspective change our experience of landscape? Thomas Baldwin was one of the first people to record his accounts of being lifted in the air by a balloon. It's kind of an interesting book. It has not only descriptions of his experience of these landscapes from new perspectives, but he also brought up a lot of instrumentation to record what barometric pressure and things like that were during his experiences. And then here at the MSU archives, one of our former students, James Diamond from geology, actually went into air photo interpretation and recorded quite a bit about his experiences within the Army Interpretation Center, and exchanged letters with the then department chair of geology, and you can see those at the MSU archives. And then finally, we have the ASPRS archives, and that's probably the largest collection of personal narratives around air photo interpretation in World War II. There's about 100 different video interviews. Only a few of them have actually been transcribed. ASPRS has fallen on hard times, and so it kind of got shelved, but we're looking to kind of bring that back. So this idea of deliberate looking and understanding the image, as this is kind of out of place. So deliberate looking, this idea of knowing exactly how you should be looking at the image instead of having an overall just experience of the image. We see it really pushed and sold by the DoD, especially a lot of the human factors research labs, from the Office of Navy Research all the way to the USAF's Human Factors Research Labs. And we see a lot of things within these different conference abstracts about how do we better train the image analyst to be less biased, to be very focused, to produce the best information, the most accurate information out of that. as we see the time go on, we shift from air photo interpretation. The human factors literature also shifts, and we start to see a focus more on things like augmented displays, interactions with driving planes, flying planes, different methods of seeing besides reading imagery. So in the late 1970s, early 1980s, we see ourselves even further removed from the idea of the individual and the image. And we see this look at using expert systems to develop these automated methods of seeing imagery. Most of the expert systems failed pretty miserably, and we kind of went back to statistical methods, supervised classification, things like that. But then we have these ideas of these new ideas about knowledge transfer, and how do we take what's in the individual, what's in their mind, and transfer that to a computational system. Expert systems were the first experiment on this. In the last 15 years, we've seen object-based image analysis come about as another new alternative way of organizing expert knowledge and applying that to satellite image analysis. A good example of this, so here is a verbalization from someone reading imagery from a North Korean missile site, actually. And so they say that color infrared imagery shows no significant indications of vegetation adjacent to the test stand being burnt from exhaust, as evidence that there haven't been any tests carried out more recently. Well, how do we actually measure that? How do we put that in parameterize that in a way that the computer understands? So if we look at what it looks like in CIR imagery, the black spots there are what's been burned in this California forest fire. I figured that was probably a good analog to it. So there's questions about how do we then package this information for a computer, whether we should even package this information for a computer. So my current research, I have a student working on looking at taking large collections of expert knowledge and parameterizing them into these object-based image analysis techniques. So we've started with a corpus of expert interpretations. We have 650 interpretations of 3 years worth, I would estimate, of high-resolution satellite images for the North Korean missile sites. And then there's 4 different interpreters with intelligence experience, many of them CIA, former USAF interpreters, and they have provided us with these interpretations that we are then coding. So we're using the image interpretation elements as a framework for kind of coding this. And then using the JDL's schema, darn it. I'm forgetting. The acronym is skipping my mind. Basically, it's an ontology of different military intelligence features that would be of importance for various applications. So we're taking the collections of interpreters, coding those, and then applying those codes to the JDL schema through the use of ontology, and then applying them to an object-based image analysis of the collection of Planet Lab imagery that we've acquired to see if it's possible to use alternative forms of expert knowledge to train our classifiers. We've seen the use of things like crowdsourced data, direct interviews. So my dissertation looked at interviews and observations with experts in forestry applications and using that to create rules for forest disturbance classification. So we're taking it another step forward and trying to remove the the need for interviews because of experts being so difficult to not work with, but get time with. So we're looking at seeing whether that works. We're also looking at, in GeoBia, we have the ability to do rule-based classification. So taking different image object attributes and then assigning them basically Boolean operators, using Boolean operators to assign them to different features. So looking forward, my research kind of has 2 different bends. I'm really interested in understanding the relationship between the individual and the image from both how it's developed throughout history, as well as how we can use that relationship to improve our current remote sensing applications. And to do this, right now I'm kind of working on how do we integrate human knowledge into the image analysis process. The majority of remote sensing research now, beyond the idea of crowdsourcing, really looks at automation, the use of artificial intelligence methods to extract information, and I'm kind of interested in how do we kind of weave humans back into that, starting first with looking at experts and how we, since they are so readily organized already because they use those image interpretation elements, that's how they discuss imagery, and then hopefully moving to other forms of knowledge, other aspects of knowledge, and how we integrate that in. And then also highlighting the stories of the individuals. So with this ASPRS project, really getting to know and understand better and tell the stories of the humans, the people that really saw this historical development. And with that, an example from Baldwin's book on his Aeropedia book on his descent into the clouds, you can kind of make out Chester there in the middle, and then some of the clouds, and then a more recent perspective on remote sensing. And then some of the various voices that I have listened to over the past few years that have really helped kind of add to my randomness, really. So, thank you.
So we'll have some questions, I hope. I'll ask that you use this microphone. This is not to amplify your voice, but just to record it for the video. So.
Thank you. That was a really exciting talk. Thank you very much. I did have a question. You mentioned that there seems to be different interpretations in terms of experts and other people, and sometimes those actually run counter to one another. How would you envisage having a computational approach that would capture that? If it seems to be, that the knowledge would actually in some ways be contradictory.
Yeah, and I don't have an answer for that as of yet. That's why we started with experts. Yeah, so one of the things that we've been working with and kind of exploring is this idea of ontologies and matching. In our case, we're using JDL, but creating our own ontologies instead of some of those more local concepts. With the dissertation research, we went from interpreters creating a model of the environment that they saw. So the CIR imagery, different values relate to different effects, and then kind of translated that into an ontology that could be brought into the GeoBia. I can envision working with non-experts but still stakeholders that have specific needs and building those same kind of networks or ontologies for inclusion. How to remedy this difference, I'm not completely sure. But it would be, I think it's an interesting question that hopefully someday I'll get to.
Thank you.
So it was interesting that you brought up Trevor Paglin, and I was actually wondering how he's kind of affected, or how he has influenced some of the things you're thinking about as well. Because he's an artist, but he was trained also as a geographer, and so he's really kind of an expert in two ways around thinking about oftentimes surveillance.
Yeah, so I had never heard of Paglin before Judith Stoddard asked me to be on this Broad writing residency. And I hadn't really thought about it as in depth. Before that, I'd only thought about experts as in how can I take those texts and how can I extract those interpretation elements and how do those relate to technology. And then after working within that group and talking to them, as well as reading Trevor's work, and then another contemporary of Paglin's who was at UCSB at the time, John Cloud, also did a lot of work on this idea of reconnaissance. And for me, it really comes into play in just kind of broadening my own idea of what am I doing as an image analyst when I have this imagery coming in and I'm creating these like abstractions of what's going on the ground, and there's people there that are part of the processes that we see played out, but they don't really get a say in whether they're part of it. I haven't dealt with it enough or thought about it enough, I think, to say much more beyond that, I guess. It's definitely something I wish that I had more time to dig into. Maybe once I have tenure and don't have to worry about that anymore, then I can start thinking of, because yeah, this is very much a random conglomeration of all these different ideas that I've kind of collected and percolated throughout the last 5 years, but haven't really taken a foothold yet, I guess. Thank you.
Thank you. This is a great presentation. I'm wondering if you could speak a little bit more about the way that what's referred to as deep learning is working within remote sensing technology and classification. Because I went to an interesting talk last week, which was in applied math, which was on algebraic
yeah,
topology.
the topological data analysis.
And the speaker said that there's apparently a deep distrust of deep learning within the Air Force and so on. So I was wondering if you could say a bit more about that.
That's funny. So I worked at the Air Force this summer with some of the members that were part of the TDA group there that were working on it. And they're trying to answer some of these questions about how can you use TDA to like differentiate between a pair of pants and a shirt. And you throw in just a couple of different features, and it just becomes a complete mess. And I think in remote sensing, it becomes even more complex because we have these very different landscapes depending on what scale you're looking at and kind of where you're looking at. So an agricultural landscape versus an urban landscape. For example, they're both very square, but the spectral features that we get, the type of information that we're getting out of there is completely different. I've seen quite a bit of work on neural nets coming out with good results. I haven't seen much on deep learning. I have to say that's not an area that I'm necessarily that familiar with. I think there's the potential there. I also think that there is a lot of questions about how much we should be applying that to these types of applications. From my own sense, as a member of the remote sensing community, I definitely see them pushing very much towards that end of automated, fast, computational success. Yeah, we'll skip that part. But yeah, that's basically, they want computation. When I tell them I talk about humans, I get very strange looks when I go to the conferences. So yeah, that's about it.
So I'll ask a question. One of the slides you mentioned power dynamics and different ways in which power dynamics can be related to this work. And I'm curious if you could just say a bit more about that. It seems to me, I think somewhat clear maybe how the access to this information and use of this information could reinforce those. I wonder if there are ways in which power dynamics figure into the acquisition of the information and then the analysis of the information as well. Anyway, I was just hoping to hear a little bit more about how that figured into the remote sensing work you do.
Yep. So a lot of the ideas, so looking at the historical data, if you look at the declassified documents, you really start to see like who's pulling the strings, who's making the decisions on what's going to be collected. Nowadays, we have such wide variety of commercial users and government users that groups like Planet Labs collect imagery daily. In fact, this morning when I looked for imagery for the slides, they had October 26, 2018 imagery of North Korea available with no problems. But during the historical period, if you look at the declassified documents, you see a lot of the decisions being made by very few people. So you look and you see, for example, I think his name's Dennis Land. And Bissell is another popular name you see. And they're the ones writing the documents saying that these are the areas of interest that we need to capture. These are the places that we should be going. And you hear about them throughout the literature if you look at the military intelligence literature or military history. But then you look at the documents more closely and you start to see a lot of people who were part of this and are erased from history. A lot of the redacted documents, for example, I came across a few that were submission for security clearance for Ms. Black Bar. And these people had decisions to make. They had a role in everything, but they've kind of been erased by the government from this whole narrative about imagery. I think also going back to the MediaSat and some of the 1980s literatures around these ideas of imagery use, we start to see a shift from, and this really worried the government, I think, when you start looking at some of the congressional hearings and the security office papers, where the government starts to feel like they're losing control of capturing the imagery. And what is that going to mean when anyone can go and look at things? But I think it's a very interesting dynamic and we see now even, like was this shift in the 1980s, and now we all have imagery, and now we really all have imagery because we can all go buy a drone, and if you're not a professor, you don't really have anybody telling you what you can fly. And so we see this whole kind of spin around to what's capable and what we can understand, and I think that's going to be an interesting area as we move forward to understand how putting technology in our own hands is going to change remote sensing.
I was interested as one, you were discussing the sublime, and kind of when I think about remote sensing, you don't think about that information. You think about it as data oftentimes, not as like imaging and sublime. But one of the images that sparked kind of the environmental movement is the image of the Earth in space, or like contextualizing a lot of that. And so I was wondering how you've thought about that kind of in the context of being able to see one work that is supposed to be classified as sublime. There's even problems with this conception of sublime, but we'll leave that be. But kind of your interpretation on dealing with that, and maybe some of your colleagues, as the way they think about remote sensing or the way they think about that imagery when conducting their work or their research.
Yeah, that's a good question. I have not wrestled with. So I guess, it goes back to this. I don't want to lay blame on the community or really be like blackballed, but we do tend to think about them as spectral features. So we have this layer of image data, and we have what the reflectance was in the red, green, and blue, and we see that only for what information is it going to give us. We don't necessarily go through this idea of, well, what does it really convey to other users? And we see with NASA in the last few years, the Scientific Data Visualization Group has worked really hard to try to integrate more remote sensing within the mainstream media, for example, and really highlight some of the more beautiful work that they do. They've done a really good job in looking at different ways to kind of evoke more of a response out of non-experts. There really hasn't been much work, if any, to think about how do we evoke some sort of a response from a data analyst. I guess one potential argument against that is we see a lot of remote sensing people who don't work in government, so like researchers, for example, often pick places that they have some sort of an attachment to. So our graduate students, a lot of them go back to their home countries or their home states and collect imagery, and they feel a connection to it that we don't generally if you're working for a large organization just doing like a full continental land cover analysis, for example. There's a lot of work being done in the cartographic realm along place and space and relationships along that. In remote sensing, though, we tend to shy away from any type of place. The idea of place isn't something that remote sensing has done a very good job addressing, much less the idea of sublime. Oh boy.
I appreciated what you had to say about visual art, and I was curious if you had any thoughts about whether there are performing artists, theater artists, or dancers maybe, or even just representation of remote sensing imagery in film.
Oh, that's a good question. Oh. I mean, I think some of the work being done in environmental documentary kind of starts to move that way. I can't say that I can think of a single example that is specifically remote sensing within film or music. Yes, Miss Stephanie.
Can I just talk loudly? Is that okay? So, because I know you, Raechel, I know that you incorporate ceramics into the classroom.
Oh,
with your
yeah.
remote sensing. So I was wondering if you could talk a bit about that.
Okay, yeah, I didn't think about that at all. Thanks, Stephanie.
You're welcome.
So, yeah, so I teach cartography, and as part of one of the projects that we do, we use clay tiles, and I give the students clay tiles about this big, and then they get a piece of a topographic map, and they transfer that topographic map into 3D, and then we fire them and hang them up. So that doesn't necessarily go back to the remote sensing. I guess if I gave them DEMs, and we would get into remote sensing using that as part of it. One application, I'm glad you said that now. So in the North American Cartographic Information Society, they tend to be more on the artistic applications of cartography. They're really welcoming for that type of thing. Back 10 or 15 years ago probably now, during one of the conferences, they painted a large swath of area that would correspond to a Landsat pixel. And so when it came over, then they were hoping that they would be in the close enough range of where the pixel would end up being at that it was captured. I don't think anybody's ever done anything with that, though. So if anyone wanted to go back to the Landsat archives and see if they could find that pixel, I'm sure you could probably do that. But that's a great question. Thank you.
I just had another question that I was thinking about when you were giving your presentation. And I was wondering where global positioning systems, if I've got the acronym correct, where that fits into the narrative in terms of when that became a public technology. I'd love to hear more about.
Yeah,
that
that's
as well.
I'm definitely not as up on the GPS history. I know that even now, we do, of course, still have the skew, like, we don't know our exact position. We know pretty darn well. Anybody that uses any running apps knows that. But it's definitely been something, I think, that has been used as kind of a control mechanism. I would be interested, though, in seeing whether, I'm sure there's a whole body within geography called critical GIS, critical geographic information science. A couple of names would be Matt Zook and Matt Wilson at Kentucky. Both study very much this idea of power relationships and the control of geographic data and our relationship with them. I haven't done nearly as much with the GPS, though.
So I'm going to be that person for just a second. This isn't actually a question, but this prompted me to think in terms of the GIS and the intersection with remote sensing about some of the art and that I've seen where people are using GPS. I said GIS, I meant GPS. They're using GPS to create shapes and to create images and how that intersects. And I'm curious if you think that that's kind of within that same realm or if it's something different, or if there are any examples that are your favorites of things like that.
Yeah, it definitely intersects. A slide that's not on this talk that was on a talk I gave last week in the psychology department was this difference between maps versus images, especially within the way that geographers kind of think about these things. So we kind of have the vector data, and then we have the raster data. And within vector data, the creation of vector data by those types of means is very different than how we've traditionally, prior to smartwatches and things like that, have thought about data collection. But when we apply them to something like a map, the goal with creating a map is generally to abstract, to generalize, to make a map so that it is specific to some application, so that only the information you need is there, where I contrast that with an image where the image captures what we think is realistic, a realistic representation that isn't necessarily the generalization, the abstraction that we see is a product of the sensor and not of the map maker in those kinds of areas. So that's kind of how I differentiate in my own mind between the two of them. But there's a lot of different applications that use GIS and remote sensing in general. So I don't know if you guys, this rug reminds me of it, but you can go and pick your favorite place and order a rug, and they'll send you a rug that's based on the aerial photography of whatever location you want. So if you wanted a map of your hometown in a rug, you could do that. And it's not your traditional cartographic map, it's the imagery of that. So you see a lot more cubist style representation in those type of products. With the GIS, well, there's the example as well of the Air Force pilot who decided to go rogue and draw his GPS coordinates over Washington State a few months ago, or maybe a year ago, I don't remember exactly. So there's a lot of examples where GIS has been used as for these types of representations as artistic expressions. I have a friend, Tom, tomake.com is his Holloway, Steve Holloway, that's better. He is originally a remote sensing analyst from the early 1980s and then transitioned into large format photography and cartography. And he uses a lot of this idea of imaging the landscape or imaging a space and applying that to art as well. Within the GIS realm, we also see quite a bit on the use of typography lately. So Axis Maps is a popular map-making consultancy, and they, for a while there, were using typography and different fonts to represent different features that were related to basically how you would classify an image. So, for example, if you had a park, that park would be filled with the park name, things like that. So there's a ton of examples of different ways in which geographic data in general have been used for artistic expression. Most oftentimes with the remote sensing imagery, you're going to see them used in, like I've said before, the environmental type books. A lot of coffee table books have used remote sensing imagery for those same reasons. So.
All right, thank you very much. I'd like to remind everyone that there will be a coffee hour from 1:30 to 2:30 in the Center for Interdisciplinarity in South Kedzie 523. If you're in the area or if you just need another cup of coffee, please stop by and hang out for a bit. We'd love to have you. Thank you.